Hello my dear friends, I am Dr. Sai Thakur, PG Scholar, is going to introduce Professor Arpis Baghel, Dean Faculty of NDVSU, who will give a scientific lecture on vitamin A and its importance in animals. Dr. Baghel has more than 40 years experience in teaching, research and extension. Dear friends, we know that vitamin A play a very important role in the body system, in animal life, in each and every activity. Now, I request to Dr. Arpis Baghel to give a scientific lecture on vitamin A.
Thanks, Dr. Sahil. Dear students, today I am going to discuss regarding vitamin A and its role in animals. Vitamin A is chemically named as retinol. It is very important nutrient, and this vitamin is 20 carbon compound, colorless, and is fat soluble. Unsaturated alcohol with 5 double bonds and long chain made up of isoprene units with alternate double bonds. Vitamin A usually occurs only in the animals, not in the plants. These are retinoids classified as retinol, alcoholic form, retinol, aldehyde form, and retinoic acid, that is acid form. The most active form of the retinoid is oil trans vitamin A. It is usually found in mammalian tissues, and when this cis form is formed from the oil trans form, there is loss of the vitamin A potency, so it must be realized. Usually vitamin A is vitamin A1, and hence other vitamin very close to vitamin A is named as A2. Only difference is there is double bond at the third carbon in vitamin A2 in comparison to vitamin A1. In marine fish liver oil, vitamin A2 is present in large quantity, but out of the total vitamin present in the marine fish, less than 10% is present as vitamin A2. The biological activity of the vitamin A2 is only 40 to 50% of the vitamin A1. This vitamin is fat soluble. It can dissolve in the fat solvents. It is insoluble in water. And the most important is it undergoes destruction during the process of storage because of oxidation process, which is favored by the amount of moisture, the air, the light. So during the process of storage, if the conditions are not optimum, there is destruction of vitamin A. Now as regards the source of vitamin A, the liver is the excellent source, richest source. And the concentration of vitamin A in the liver, it depends on the species of animal and depends on the concentration of vitamin A in the diet of the animal. As I have told, fish liver oil is the excellent source. In whale fish liver oil, vitamin A is present as 10,000 microgram per gram of oil. So see how much rich vitamin A is in the whale oil. And as compared to that, in Hollywood fish liver oil, it is 6,000 microgram. In shark liver oil, 4,000. Codfish liver oil, 1,000 microgram per gram of oil. Thus, fish liver oil, they are excellent, richest source of the vitamin A. In the liver of the animals, in pigs, concentration is around 30 microgram per gram of liver. in sheep 180 microgram, and in hens 270 microgram per gram of liver. Thus, these livers, especially the chicken liver, hen liver, that is also very good source of the vitamin A. Besides egg yolk and the milk fat, they are also very good sources of vitamin A. Usually the vitamin A is expressed in units, and the unit internationally is termed as international unit. If we define the international unit, so it can be defined as the biological activity of 0.3 microgram of vitamin A alcohol, that is equivalent to 1 international unit. Similarly, 0.55 microgram of vitamin A palmitate and 0.6 microgram of beta-carotene, they are equivalent to 1 international unit. Usually, instead of international unit, many times the retinol equivalent is used, and 1 retinol equivalent is equal to 1 microgram of retinol, 6 microgram of carotene, and 12 microgram of other provitamin A carotenoids. Many times the question comes, what is vitamin A value? So dear students, vitamin A value can be defined as the combined potency of a particular feed represented by its vitamin A value and carotene content. So vitamin A and carotene, both they combine together, they give more vitamin A value, and that is called as vitamin A value of the feed. Now besides vitamin A, the vitamin A can be synthesized in the body through the precursors, and these precursors they are called as provitamin A. Usually in the nature, more than 600 naturally occurring carotenoids are available, but only few are precursors. And these carotenoids, they are mainly carotenes, Cryptoxanthin. They are very important provitamin A. Among the carotenes, those which has vitamin A activity, that is alpha-carotene, beta-carotene and gamma-carotene, but the beta-carotene is biologically most active. If we see the biological activity of different carotenes in comparison to beta-carotene, the alpha-carotene has only about 25% activity, gamma-carotene about 14% activity, and cryptoxanthin 29% activity. So among all these provitamins, beta-carotene is excellent as a precursor for vitamin A. Among the sources, fresh grasses, they are the very rich source, good source. As regards the value of carotene, it is around 33 to 88 milligram per kg of the green, depending on the leaf proportion in the greens. Now this carotene content of the greens can be destroyed, can be reduced during processing method because of exposure to sunlight, because of oxidation, during the process of drying, haymaking, lot of destruction of carotene and vitamin A potency is reduced. For example, when the lucerne is dried artificially with optimum conditions, it contains 95 milligram of beta-carotene per kg of hay. On the other side, when the lucerne has been prepared in the normal condition, natural condition, its carotene content is only 15 milligram per kg. So we can realize there is 6 times reduction in the potency of beta-carotene because of lot of drying method, exposure to sunlight. Now as regards the digestion of these vitamin and carotenoids, in the food material they are present in the protein bound form, and when they reach to the stomach with the help of enzyme pepsin, that is hydrolyzed to some extent, and then when reaches to the small intestine, then with the help of proteolytic enzymes, these are hydrolyzed, and then when reaches to the duodenum, then they are mixed with the bile salts, emulsification, and further breakdown of the fatty globules of these carotenoids and retinal esters. As a result, they are further reduced into smaller particles, and then they are easily digested by the help of pancreatic enzymes. Three pancreatic enzymes are playing very important role for digestion of these carotenoids and retinal esters. One is pancreatic lipase, other is retinal ester hydrolase, and third is cholesterol ester hydrolase. So these three important enzymes, they causes hydrolysis in the intestine. This carotene is converted to vitamin A in the intestinal mucosa in most of the animals and in the liver. There are two important theories for conversion of carotene to vitamin A, or you can say for degradation of carotene. One is central cleavage theory, means beta-carotene degrades centrally, and other theory is step oxidation of beta-carotene. In both the process, beta-carotene is under destruction. Some amount is lost. Chemically, beta-carotene is double to that of retinol, but it won't give 2 moles of retinol. Only 1 mole of retinol is available from hydrolysis of beta-carotene. Now this beta-carotene is hydrolyzed into enzymes, two important enzymes, that is beta-carotene 15,15 dioxygenase. First important enzyme that is responsible for cleavage of beta-carotene at central double bond. This much of the conversion process takes place in the intestinal mucosa and then in the liver and in the other organs also, especially in case of poultry. But in the species like rat, pig, goat, sheep, rabbit, buffalo and dog, almost all the carotene is cleaved into intestine itself. Now second enzyme is retinaldehyde reductase, which reduces retinol to retinol, from aldehyde to alcohol. So these two important enzymes are essential for conversion of beta-carotene to retinol. In some of the species like cat or mink, the cleavage enzyme, that is beta-carotene 15,15 dioxygenase, is not available. Hence, these animals, cat, mink, they cannot utilize carotene for conversion of vitamin A. Now, if we see the efficiency of conversion of beta-carotene to vitamin A, in case of rats, 2 mg of beta-carotene can give rise 1 mg of vitamin A. So it is in the ratio of 2:1. In other species, this ratio varies from 3:1 to 12:1. In case of poultry, this ratio is 3:1. In the ruminants, 6:1, and in case of pigs, 11:1. So most efficient is rat, followed by poultry, then ruminants, and least efficient is pig, where 11 mg of beta-carotene can give rise only 1 milligram of vitamin A. Now these vitamin A and carotene, they are stored mostly in the liver, and it has been noticed that more than 20% of the total body vitamin A is stored in the liver, and the remainder amount is stored in the kidney, lungs, adrenals, blood, and with a small amount in different other organs of the body. There is specialty in case of cat and dog. In case of cats and dog, the large quantity of vitamin A is stored in the kidney as well as in the liver. In case of cattle, when they are fed large quantity of greens, then beta-carotene and vitamin A that is stored, and in the animals where the carotene is completely utilized in vitamin A, in that case the body fat is white, the milk is white in color, and in the species or in the breed where the beta-carotene can be absorbed as such, in that case the milk is yellowish in color, the body fat is yellowish in color. Regarding the absorption of these carotenoids and vitamin A, in the stomach practically no absorption. The main site of absorption is the mucosa of proximal jejunum. Vitamin A is 80 to 90% absorbed and beta-carotene only 50 to 60%. So absorption of vitamin is very efficient. Now within the mucosa, vitamin A is absorbed as retinol, and then it is re-esterified with palmitate and enclosed as chylomicron, which adjusts from the mucosa and is secreted into lymph, from where it is circulated and deposited. It is mainly deposited in the hepatocytes and stellate cells and parenchymal cells of the liver. The efficiency of absorption of vitamin A reduces depending on the intake. If the intake is very high, then efficiency of absorption reduces. Now regarding the transportation, the retinol that is transported in the body through a specific transport binding protein, and that is called as retinol binding protein or BP. This protein is synthesized and secreted by the hepatic parenchymal cells, and this hepatic parenchymal cell synthesizes the RBP, and this synthesis is regulated by estrogen and the nutritional status of vitamin A, protein and zinc. In birds, this retinol is readily transferred to the eggs and that is deposited. But in case of mammals, the placental barrier is there. So across the placenta, transfer is very poor and it is very marginal. In case of mammals, which are born with very low stores of liver vitamin A. But in case of cattle, you can realize there is a strong breed difference. In Holstein Friesian, they are very efficient converter of carotene to vitamin A. But in case of Guernsey, in case of Jersey breed, the carotene can be readily absorbed and deposited in the body fat and in the milk. As regards the functions of vitamin A, it is very important, most important nutrient that supports the growth of the animal, very important for the health of the animals, and very important for overall life of the animals. retinol, the most important component, is very, very important for various functions. But besides the retinol, retinoic acid is also very important. Retinoic acid is working like a hormone. It supports only growth and tissue differentiation. But retinoic acid is not playing any important role in the vision or in the reproduction. As a hormone, retinoic acid regulates transcription activity of a large number of genes that is very important for the growth. The main action of vitamin A in the development and differentiation and metabolism in the body is mediated by nuclear receptor proteins. The two important nuclear receptor proteins are retinoic acid receptor proteins, and second is retinoic acid receptor X protein. Retinoic acid X receptor protein and retinoic acid receptor protein, they play a very important role. These nuclear receptor proteins, they have important role. They bind with the retinoic acid with the steroid and thyroid hormone receptors, and then they interact with the specific genes and regulate their transcription. So retinoic acid plays very, very important role in the transcription of genes. This retinoic acid again plays very important role in the growth and differentiation of embryonic tissues. And secondly, it also regulates differentiation of epithelial, connective and hematopoietic tissues. Thus, vitamin A, overall, retinoic acid plays very important role, but in the vision, role is mainly played by retinol. Now, vitamin A is needed for integrity of visual cells as well as their normal regeneration. So, vision, very important component of the body, and that is regulated by the cells of the retina, the rod cells. They are very important for vision in the dim light, and cone cells, they are very important for bright light and color vision. Now when the light falls on the retina, then with the help of photons, that rhodopsin is broken down into retinine plus opsin, and opsin is a protein certainly circulating and again available, but that transretinol is again converted into cisretinol with the help of enzyme, retinal isomerase, and then that combines with the opsin protein, and then again the prosthetic, that is pigment rhodopsin, is available for vision purpose. During this process of breakdown of rhodopsin, some of the retinol is lost, and that has to be made up through the blood vitamin A. If that is not maintained, then body storage is utilized, and gradually, if the diet is deficient, then deficiency will occur. Now, rhodopsin, when it is broken down because of exposure to light into opsin and all-trans retinol, this all-trans retinol also circulates in the blood and goes to the liver. In the liver, this can be, or this is converted into oil trans retinol, alcoholic group, and with the help of enzyme, alcoholic dehydrogenase in the liver, and then the oil trans retinol is isomerized in the 11-cis retinol, and this 11-cis retinol, again with the help of enzyme, alcoholic dehydrogenase, that is reduced using reducing agent, that is converted into, that is oxidized into 11-cis retinol. So this 11-cis retinol combines with the option and gives rise to adoption. Second most important function of vitamin A, which is required for maintenance of epithelial cell. These epithelial lining, they are the very good protective lining in the different organs, different systems like respiratory system, gastrointestinal system, and urogenital tract. And the eye, they are protected because of this mucous membrane. Vitamin A here is very important for formation of mucopolysaccharides. And these mucopolysaccharides containing glucosamine, so glucosamine synthesis, mucopolysaccharide synthesis, this is regulated by vitamin A. These mucopolysaccharides, they occur in different tissues and mainly in the mucosecreting epithelium and in the extracellular matrix of cartilage, which is present as chondroitin sulfate. So, synthesis of mucopolysaccharides, that is very important, and it is played by, important role is played by vitamin A. Next important role of vitamin A is in the biosynthesis of glycoproteins. These glycoproteins, they are the very important constituent of cell membranes. So to maintain the integrity of the cells, glycoprotein is required and its synthesis is regulated by vitamin A. Thus, this vitamin A has capacity to change the permeability of lipoprotein membrane of the cells and of the intracellular particles. And how this role is played by vitamin A? This vitamin A penetrates the lipoprotein membrane and acts as a cross-linking agent between lipid and protein and thus stabilizes the membrane. So vitamin A is playing very important role in maintaining the health of epithelium, in maintaining the integrity of the cell membrane. It also plays very important role in reproduction. Healthy reproduction can be only possible if the epithelium of the reproductive system, germinal epithelium, that is in very good position. Normally, healthy epithelium is responsible for good reproduction. If epithelium is not maintained healthy, it will lead to reproductive failure. Other important role of vitamin A is played for the formation of bones, bone matrix formation, cartilage formation, and that requires chondroitin sulfate. This synthesis of the chondroitin sulfate is controlled by vitamin A. By controlling gene transcription, there is synthesis of protein. Protein matrix is formed, and then there will be deposition of chondroitin sulfate, then only bone formation can be good. And vitamin A is very important role playing here for normal development of bone through control, exercise over activity of osteoclast. If the osteoclast activity is not normal, then osteoblasts, they will multiply and there will be abnormal bone formation. And to maintain the normal bone formation, the activity of osteoclast is very important which is regulated by vitamin A. Thus, vitamin A, through gene transcription, through maintaining the healthy epithelium, plays very important role for the health, for the growth, for the bone formation, for the reproduction, and for other body functions. Thank you very much.